Hello ladies and gentlemen. Welcome to my channel Imagine a Time Before Time. A place where no stars existed, no atoms, no space, no laws, just nothing. Or was there? Today, we're diving into a question that has haunted scientists and philosophers alike for centuries. Did nothing ever truly exist? We're about to uncover whether the idea of absolute nothingness is just a human illusion or if there really was a moment when the universe was truly, completely empty. This isn't just a scientific mystery, it's a riddle that questions the very roots of our existence. Let's solve it. In the beginning, there was nothing, or so we've been told. But nothing is tricky, nothing is weird, nothing is something worth exploring. Not because it's empty, but because it holds the answer to everything. What if I told you that nothing has never truly existed? That even in the darkest corners of the universe, silence is not silent, emptiness is not empty, and nothing is just another name we give to something we don't yet understand. We talk about nothing all the time. There's nothing in my pocket, there's nothing on the table. But in reality, there's air, molecules, atoms, light bouncing around. In science, nothing doesn't mean the same as it does in daily life. And that's the first problem. We don't even agree on what nothing means. Is it the absence of matter? The absence of energy? The absence of laws? Or the absence of even space and time? The idea of nothing isn't new. Greek philosopher Parmenides claimed, "Nothing cannot exist." To him, the idea of nothing was logically impossible. Meanwhile, in ancient India, Buddhist and Hindu texts spoke of cycles of creation and dissolution, universes rising and falling, surrounded by a kind of void. But even that void had a purpose, a role. So even back then, nothing was complicated. If by nothing, we mean no particles, no light, no space, no time, no laws, then, by all current scientific understanding, the answer is likely no. Not in any way that we can test, observe, or even clearly define. Even the nothing before the Big Bang might have had energy, randomness, or unstable quantum states, which means that reality might have never truly known nothing. Just maybe nothing never existed. What do we really mean when we say nothing? It's one of those words that sounds simple until you try to define it. Nothing, an empty box, a blank page, a dark room with no sound, a void. But the moment you try to imagine it, something appears. Darkness itself is something. A blank page is still a page. An empty box still exists. So what is nothing really? From the moment we're born, we interact with a world made entirely of something. Even when we close our eyes and lie completely still, the mind doesn't go silent. Thoughts, memories, the soft beat of the heart, they all keep reminding us, you are still here. There is still something. So then, what would it mean for nothing to exist? You see, in philosophy and in science, nothing has always been slippery, a shapeshifter. In philosophy, it becomes a logical problem. In science, it becomes an experimental one. And in human thought, it becomes almost impossible to hold without it turning into something else. Let's start with the everyday definition, the one you and I use all the time. When you open the fridge and say, "There's nothing to eat," you don't mean it's filled with the vacuum. You mean, there's nothing you want. When someone asks what you're thinking, and you reply nothing, you don't mean your mind was a perfect zero, you just mean nothing worth mentioning. So already, we can see that our everyday use of the word doesn't help us when we try to ask deeper questions. In science, though, nothing takes on a more serious role. We want to know what happens in empty space. We want to know what was there before the universe began. We want to understand if there ever was, or could be, a state of absolute nothingness. No particles, no light, no energy, no time, no laws, not even space itself. But here's where it gets strange. Because the moment we try to describe nothing scientifically, we run into the problem that to describe something, we must make it something. Take, for example, the idea of a vacuum, a region of space that has no matter, no gas, no particles, no dust. We think of it as empty, but quantum physics teaches us that even a perfect vacuum is teeming with activity. Particles briefly pop into existence and disappear again. Energy fluctuates. Virtual particles collide and cancel each other out. This is not science fiction. This is known as vacuum fluctuation, a well-tested part of quantum field theory. So now, we must ask, if even a vacuum isn't truly nothing, then has nothing ever existed? And could it? When we reach back into the earliest moments of the universe, back to the Big Bang, or even before it, we are not asking small questions. We're asking questions about origin itself. What did the universe come from? Was there a moment when there was no space, no energy, no laws, just nothing? And here's the strange part. Some scientists believe the universe could have come from what they call a quantum vacuum, kind of quantum nothing. But this nothing is still governed by rules. It has energy. It is unstable. It's not nothing in the way you might imagine, like an infinite black stillness with no form and no structure. It's more like a resting point of potential, a moment where something was bound to happen. So even here, nothing is more like a silence before music, not the absence of music entirely. Let's zoom out a bit. Philosophers, too, have wrestled with this word. The Greek philosopher Parmenides argued that nothing cannot exist, that even speaking of nothing gives it form, turns it into something. To him, there was only being, the permanent and changing existence. Later, Heidegger would ask a haunting question: why is there something rather than nothing? This single question lies at the root of metaphysics, physics, and theology. Why is there anything at all? Why are there atoms and galaxies and minds and trees and rivers and love, instead of a perfect, silent, eternal nothing? This question might feel meaningless at first until you realize how strange our existence truly is. Because we take something for granted, we wake up into a world that already exists. The air is already here. The laws of physics already work. Our minds are already running. But why? Why do these things exist instead of not existing? Some people argue that nothing is more natural than something, that perhaps it takes a cause to produce something, but nothing just is. But then again, we have never observed true nothingness. And if we've never observed it, then how do we know it's even possible? Maybe it's not. Maybe the idea of nothing is just an abstraction, a placeholder, a word we use to describe something we cannot yet define. Or maybe it's a mental trick, the way we imagine death or emptiness or sleep. By subtracting all the things we're used to, we try to remove until there's nothing left. But what if there's always something left? Even if you imagine a universe with no planets, no stars, no matter, you're still imagining space. Even if you imagine absolute stillness, you're still imagining time passing through that stillness. It's hard, maybe impossible, to imagine absolute nothing, because even the concept requires a framework. You need a place to imagine the nothing. You need a you to think it. You need words to shape the thought. You need contrast, a before and after something, and then its absence. In other words, the idea of nothing only exists relative to something, and without something, there's nothing to compare it to, and so, nothing to even think about. So now we come back to the question, what do we mean by nothing? Do we mean a vacuum without particles? Do we mean an empty space without structure? Do we mean a timeless, spaceless non-existence? Do we mean the absence of everything, including possibility itself? And if that's what we mean, then maybe the answer isn't found in physics or mathematics or even philosophy. Maybe the answer is this: nothing is not a thing. Nothing cannot exist because the moment it exists, it is no longer nothing. The idea of nothing may only live in the human mind, a shadow cast by the light of something. And perhaps that's why we can never find it, because we're always here, and here is something. Long before telescopes, quantum fields, or particle accelerators, humans looked up at the night sky and asked questions that had no clear answers. They wondered what the universe was made of, what lay beyond the stars, and perhaps most strangely of all, they wondered if there was ever truly nothing. The modern mind, It might seem strange that people who lived thousands of years ago, with no access to the tools of modern science, could even begin to imagine what nothing is. And yet, some of the earliest philosophers devoted their lives to this very question, not because they had data, but because they had something else: silence, time, and the aching curiosity of the human spirit. In ancient Greece, where the roots of Western philosophy first took hold, thinkers didn't agree on much. But they did agree on one thing: understanding the nature of existence was the most important question of all, and you cannot understand existence until you confront its opposite, non-existence. One of the earliest voices in this conversation was Parmenides. He lived over 2,500 years ago, and he made a bold claim: nothing cannot exist. To Parmenides, the very idea of nothing was impossible. You couldn't think about it, you couldn't speak of it, you couldn't even imagine it, because the moment you did, it became something. In his view, only being is. There is no becoming, no change, no void, just pure, unchanging presence. This view, strange as it might sound now, had deep consequences. Because if there could be no nothingness, then change itself must be an illusion. If what is not can never be, then nothing can ever emerge from non-being. The universe, in this view, is full, eternal, and unmovable. That's not just philosophy, it's a metaphysical wall against the very idea of the universe having a beginning, or ending, or being born from nothing. But not everyone agreed with Parmenides. A younger philosopher, Democritus, offered a different view, one that feels surprisingly modern. He believed that everything is made of tiny, invisible particles called atoms. But here's the twist: these atoms floated in the void, a kind of space between things, a blank background, a nothing. So in Democritus' world, nothing did exist. It was the space between the somethings. It didn't have weight or texture or form, but it allowed atoms to move, to combine, to become the world we see. This idea, the existence of a void, was radical. It gave structure to change, motion, and time. It suggested that without nothing, there could be no something in the way we experience it. Meanwhile, in the East, different philosophical traditions were forming their own relationships with the concept of nothingness. In ancient India, thousands of years ago, the sages of the Upanishads and later texts spoke of the cosmos not as a one-time creation, but as a cycle, a pulsing rhythm of birth, death, and rebirth. The universe would emerge, expand, collapse, and then vanish into a kind of nothing, only to be born again. But this nothingness wasn't absolute. It wasn't a blank slate or pure emptiness. It was more like a sleeping potential, a kind of cosmic womb. In Sanskrit, the word nayat, often translated as emptiness or voidness, came to represent not absence, but openness, formlessness, the space in which all things could arise. Later, in Buddhist philosophy, this idea of emptiness took on even more depth. The Buddha did not teach about a beginning of the universe in the way modern cosmology might try to explain. Instead, he pointed toward the impermanence of all things, and the idea that all phenomena are empty of a fixed, unchanging self. Emptiness, in this view, was not nihilistic or hopeless, it was liberating. It meant that nothing was permanent, and therefore, nothing was bound to suffering forever. In these traditions, nothing was not the end of meaning, it was the beginning of wisdom. It taught humility. It reminded us that everything we see is fleeting, interconnected, and conditional. The great cosmic dance was not between being and non-being, but between form and emptiness, presence and absence, light and shadow. Traveling further east, in Taoist philosophy from ancient China, we find another view entirely. The Tao Te Ching, attributed to Laozi, opens with a simple but mysterious line: the Tao that can be spoken is not the eternal Tao. It speaks of the Tao, or the Way, as the source of all things, a principle that precedes form, words, thought, and being itself. In this view, non-being is not the opposite of being, but its companion. The Tao gives birth to both. One cannot exist without the other. The very idea of a cup, for example, depends on the empty space inside. It's the emptiness that makes the cup useful. So too, in life, it's the stillness between sounds, the pauses between breaths, the space between stars that gives everything else its meaning. Here, nothing is not a mistake or a void to fear. It is the canvas on which everything else is painted. Back in the West, centuries later, thinkers in the medieval and Renaissance periods began to ask theological versions of the same question. If God created the universe, what did he create it from? If everything came from something, then did he create something from nothing? Creatio ex nihilo. The Christian doctrine of creation from nothing became a cornerstone of Western religious philosophy. But even here, there was tension. How can nothing produce something? How can an eternal, perfect God act in time? What was before creation? Was there ever a time when only God existed and no world, no time, no space? These were not just religious questions. They were metaphysical ones. They challenged the very boundaries of thought. And yet, all these centuries, all these cultures, all these thinkers circling one single idea, and again, trying to understand what it means for nothing to be real. Was it a space, a pause, a silence, a void, a potential, or was it just a word, a placeholder for our ignorance? Even now, with all our physics and philosophy and mathematics, we find ourselves strangely close to those first thinkers, looking out into the stars, looking inward into thought, wondering if the universe began from nothing, or if it was always, in some form, already here. Whether we call it emptiness, void, niyat, the Tao, the quantum vacuum, or the formless before the form, it seems that nothing has always been more than just a lack. It's been a presence, a mystery, a mirror. When you look up into the night sky and see the spaces between the stars, what do you imagine is there? A black void, an infinite nothingness, a cold, silent, empty stretch of forever? That's what most of us used to think. That space, the stuff between things, is empty. Purely, perfectly, permanently empty. But it is n single quotes t. In fact, the more we study the universe, the more we begin to understand that empty space is not only not empty, but it might be more alive, more active, and more mysterious than the matter it surrounds. Let's start with the classical view, the one held before the rise of quantum mechanics. For centuries, people believed in what was known as the ether, a hypothetical substance that filled the universe and allowed light to travel through it. Just as sound needs air to move through, this ether was thought to be invisible, weightless, and everywhere, filling the gaps between stars, planets, and galaxies. But then, in the late 19th century, experiments like the Michelson-Morley experiment failed to detect this ether. It was a devastating blow. If light didn't need a medium, then what, exactly, was space? Was it just nothing? Enter Einstein. With his theory of general relativity, space was no longer a passive stage where things happen. It became dynamic, a flexible, bendable, stretchable thing. Gravity wasn't a force pulling objects, but rather the warping of spacetime itself. Mass told space how to curve, and curved space told mass how to move. This was the first hint that space, even empty space, was doing something. It wasn't a backdrop. It was part of the play. But the real surprise came with the birth of quantum mechanics. Suddenly, the universe got fuzzy. At the smallest scales imaginable, way beyond atoms, beyond electrons, beyond even the particles that make up protons. Things don't behave the way we expect. There's no longer a clean distinction between something and nothing, between existing and not existing. In quantum theory, the vacuum which we might think of as completely empty is actually restless. It's like a quiet pond, with invisible ripples. It looks still, but it's buzzing beneath the surface. This buzz is known as vacuum fluctuation. In quantum field theory, every point in space is associated with quantum fields, these invisible layers that stretch across the universe. And even when there's no particle, no energy that we can measure, these fields never lie completely flat. They always fluctuate. These fluctuations can briefly give rise to virtual particles, particle-antiparticle pairs that pop into existence and disappear again. all within a time span so short it's governed by the uncertainty principle. It might sound imaginary, but it's not. We've detected their effects. For example, there's something called the Casimir effect. If you place two very thin metal plates extremely close together in a vacuum, so close that only certain wavelengths of vacuum energy can fit between them, the pressure from the outside vacuum fluctuations is slightly stronger than the pressure between the plates. This causes them to move toward each other, not because of any direct force, but because of the invisible pressure of nothing. That's the vacuum doing something. It gets stranger. There's also the Lamb shift, observed in hydrogen atoms. It's a small shift in the energy levels of electrons that can only be explained if you consider that even in the vacuum around the atom, there's a sea of fluctuating energy. Empty space actually modifies how particles behave, how they exist. So now, we know that what we once thought of as a perfect nothing is actually a seething sea of potential, a field that gives rise to virtual particles, influences forces, and can even push physical objects. In a way, vacuum energy becomes a form of something, not a solid something, not even a gas or plasma, but an energy so fundamental, so built into the fabric of reality, that we cannot escape it, not even in the most perfect, isolated, empty void imaginable. But this isn't just about tiny things. Empty space plays a role on the largest possible scales. In cosmology, the study of the universe as a whole, we discovered something else hidden in the vacuum: dark energy. In the late 1990s, scientists observing distant supernova noticed something strange. The universe wasn't just expanding, it was accelerating in its expansion. That shouldn't have been possible. Gravity should have been slowing everything down. So what was pushing everything apart? The answer: a mysterious force filling the universe, exerting a kind of anti-gravity effect. That force, which we now call dark energy, might be the energy of empty space itself. It makes up nearly 70% of the total energy in the universe. So if we add that to the quantum fluctuations and virtual particles, and the dynamic fabric of spacetime, we find that empty space isn't just not empty, it's absolutely packed. Packed with invisible energy, packed with potential, packed with laws we still don't fully understand. Even the Higgs field, which gives particles their mass, is spread across all of space. Every second, we exist inside this invisible field. We move through it, it surrounds us, and without it, the particles that make up you, me, and everything else would be massless. So what, then, is a vacuum? Is it the absence of matter? Is it the lowest possible energy state? Or is it a dynamic playground for fields, particles, forces, and fundamental rules? In quantum electrodynamics, we describe the vacuum as the ground state of a field, not the absence of the field itself. And this ground state has energy. Not much, but not nothing. The deeper we go, the clearer it becomes that nothingness, true, absolute, perfect nothingness, might not exist. Not because we haven't found it yet, but because physics itself doesn't seem to allow it. The universe doesn't appear to know how to be still. It hums, it ripples, it pulses with possibility. And so what we once thought of as a void might actually be the foundation of everything. It's no longer the absence of something, it's the birthplace of something. Not after time, or before time, but within the very structure of reality itself. The emptiness between the stars, the space between atoms, the silence between thoughts. It's not dead, or quiet, or meaningless. It's alive. It's fluctuating. It's full of invisible forces and flickers of energy we're only beginning to comprehend. Empty space, in the truest sense, may not be empty at all. Sometimes, when you walk outside at night and look up, it's easy to believe the universe is quiet. The stars are still, the sky is cold, and the space between them feels like a black, silent canvas. But appearances deceive. What looks like stillness is actually history frozen in motion. What looks like darkness is filled with light we can no longer see with our eyes, but can still hear with our instruments. Long before we had satellites, long before we even had a word for galaxy, the universe left behind a whisper, a signal, a kind of echo, and that echo is still here, surrounding us, filling every direction, speaking of a time when everything we now know was packed into a glowing, seething sea of energy. That whisper is called the cosmic microwave background. It is not just a piece of evidence, it's a message. It tells us a story about the earliest moments of our existence, and maybe more importantly, it suggests that true nothingness never really had a chance to understand why. We need to go back, not just centuries or millennia. We need to go back 13.8 billion years, to the very birth of the universe as we know it, to a moment often called the Big Bang. Now, the name Big Bang can be misleading. It wasn't an explosion in space. It was an expansion of space. There wasn't a quiet darkness suddenly ruptured by light. There was no darkness at all because there was no space to be dark, no time to tick, no emptiness to be filled. And yet, there was something, a point of origin, a primordial beginning, everything compressed into a tiny, incomprehensible singularity, smaller than an atom, denser than a black hole, hotter than anything our minds can grasp. Then, something changed. The universe began to expand. Faster than the speed of light, space-time unfolded. Particles formed, collided, annihilated, reformed. For the briefest fraction of a second, everything was wild, unstable, chaotic. There were no stars, no atoms, no shapes, just a glowing, fluid plasma so hot that even light couldn't travel freely. In that early universe, photons, the particles of light, were constantly bouncing off free electrons. The universe was opaque, like the inside of a furnace, churning and blinding. But as the universe expanded, it cooled. After about 380,000 years, it reached a temperature low enough for electrons and protons to finally combine into hydrogen atoms. And when that happened, something extraordinary took place. Light was finally free. Photons no longer scattered with every step. They could travel in straight lines. They could stretch. They could wander, and they did. They've been traveling ever since. That light, those very same photons, are still out there, still moving, still whispering the story of the universe's childhood. And because the universe has been expanding for nearly 14 billion years, that light has stretched too. What began as visible, blazing light has now cooled into microwaves, a soft, nearly uniform glow that fills the sky in every direction. This is the cosmic microwave background, or CMB. We didn't discover it until 1965, quite by accident. Two radio astronomers, Arno Penzias and Robert Wilson, were trying to tune a satellite antenna in New Jersey, but they kept hearing a strange, persistent noise, a hiss that came from everywhere, no matter where they pointed the dish. At first, they thought it was interference, maybe bird droppings on the equipment, but it wasn't. It was the oldest light in the universe. It was the afterglow of creation. What they had found was more than a signal. It was proof. Proof that the universe had a hot, dense origin. Proof that it was once filled not with silence, but with energy and light. Proof that even when we rewind the clock as far as physics allows, we never reach true nothingness. Because there's always a trace, always a footprint. Since that discovery, the CMB has been measured in astonishing detail. Satellites like COBE, WMUP, and Planck have mapped its tiny fluctuations, minuscule differences in temperature, like wrinkles on an ancient skin. These variations are incredibly small, just 1 part in 10000, but they're the seeds of everything. Those slight irregularities in the CMB are what allowed matter to clump together over billions of years to form galaxies, stars, planets, and eventually us. Without those fluctuations, the universe would be smooth and sterile, no structure, no stars, no life. So this ancient light doesn't just tell us that something existed. It tells us that something was already happening. And here's the strange thing. Even though the CMB represents a universe that is almost perfectly uniform, it is not perfectly uniform. Those tiny, tiny fluctuations mean that the universe was never fully symmetrical, never fully balanced, never fully empty. There was always a tilt, a bias, a tendency, a nudge toward becoming, which means that the earliest observable state of the universe was not still, not blank, not truly nothing. It was full of energy, full of structure, full of the potential to become everything, and even now, the CMB continues to stretch as the universe expands. Its temperature, once thousands of degrees, is now just 2.7 Kelvin, barely above absolute zero, and yet, it's still there, still moving, still speaking. If you could see microwaves, the night sky would glow, not with stars, but with memory. Every patch of sky would hum with the echo of that early light. Every direction you looked would take you back in time. And what does that tell us? It tells us that even space, when it appears empty, holds the past. It tells us that nothing has a hard time staying nothing, because when we look as far as we can see, when we reach as far back as physics allows, we don't find a void, we find a fog of light, we find patterns, we find warmth that has nearly cooled into silence, but not quite. We find the fingerprints of a universe that was never truly quiet, a universe that has always had something to say. The moment we hear the words Big Bang, our minds often fill with fireworks, an explosion, a flash, a beginning. We're told that the universe began with it, that space and time themselves were born from it, that everything we've ever known, every galaxy, every atom, every heartbeat was once compressed into something smaller than a grain of sand. And yet, once you start thinking about the beginning, a question quietly appears. One that never fully goes away. What was there before? It's a question that sounds simple, but it's anything but. Because when we say before, we're invoking time. We're reaching backward. We imagine a ticking clock and then ask what the previous tick might have held. But if time itself was born in the Big Bang, then what does before in me? Physics doesn't always work in human language. And this is one of those moments where the words we use can't quite keep up with what the equations suggest. The idea that time had a beginning is not just poetic, it's a result of general relativity. When we trace the expansion of the universe backward using Einstein's equations, we don't just shrink space, we also shrink time until it reaches what appears to be a singularity, a point of infinite density, infinite temperature, infinite curvature, a place where our current models collapse not because they're wrong, but because they were never meant to go that far. In this singularity, the normal rules of cause and effect break down. Time, as we know it, no longer ticks forward, space no longer stretches, and in that silent collapse, the question, what was before, becomes hard to even ask. But that doesn't stop us from trying. Some scientists and philosophers believe the Big Bang was not the absolute beginning, but a transformation, that instead of emerging from nothing, the universe transitioned from a previous state something else, something different, something we still struggle to imagine. One idea is the cyclic universe, a cosmos that expands, slows, contracts, and bounces back in an eternal rhythm. In this model, the Big Bang is just one beat in an infinite drum. What we call the beginning is really just a rebound from a previous universe that collapsed. Time may be a circle, out a line. Others have suggested the ekpyrotic model, where our universe was born from the collision of higher dimensional brains. According to string theory, our universe may be a three-dimensional slice floating in a higher dimensional space. If two such brains collided, the energy of that impact could spark a new universe. The Big Bang, then, would not be a start from nothing, but the result of cosmic geometry playing out in higher realms. There are also models of quantum tunneling, where our universe may have emerged as a kind of fluctuation from a pre-existing quantum vacuum, a state not of emptiness, but of potential. In this view, there may be an endless sea of possible universes, each bubbling into existence through a quantum event, like steam rising from boiling water. Our universe is just one bubble among countless others. The question of before becomes, in this light, less about a timeline and more about a condition. What kind of reality could exist without time? What kind of nothing could give rise to everything? And then, there is loop quantum cosmology, field that tries to unite quantum mechanics with general relativity. In this model, space is Not continuous, but made up of discrete chunks, tiny loops of spacetime geometry. As we approach the Big Bang, the energy density increases, but instead of reaching a singularity, the model predicts a quantum bounce. The collapsing universe reverses direction and begins to expand. If this is true, then the Big Bang was not a birth, but a bounce. Before our expansion, there was contraction. Before our light, there was another light, long extinguished, but even. These ideas, as elegant as they are, turn into deep questions. If the universe bounced, where did the first contraction come from? If it fluctuated into being, what existed before the fluctuation? If it emerged from a timeless quantum state, how did time begin? At some point, we find ourselves standing in front of a mystery that seems less like a problem to solve and more like a veil we cannot yet lift. And so, some turn to philosophy. If nothing existed before the Big Bang, then how can we speak of existence itself? Can something truly come from nothing? Or was there always something, perhaps not matter, not space, not time, but possibility itself? In ancient times, thinkers would invoke a first cause, or a prime mover, something outside of time, untouched by causality, that brought everything into being. Modern cosmology doesn't require such an entity, but it hasn't fully explained how time and energy could spontaneously arise either. One possibility is that the universe simply is a brute fact, uncaused, without origin, that it exists not because it must, not because it was created, but because reality itself has no alternative. In this view, the universe didn't begin from nothing, because nothing is not a real option. Still, the human mind struggles with this idea, because in our daily lives, every effect has a cause, every moment has a before, every story has a beginning, and when we try to imagine a time before time, place before space, a cause before causes, our imagination slips, our metaphors fail. We're left staring into a silence that no language can fill, but even in that silence, there is wonder, because the more we ask what came before the Big Bang, the more we find that our understanding of beginnings and of nothingness itself is limited not just by tools or theories, but by the shape of our own perception. Time may not have a start point, like a race. It may be woven into the structure of the universe in ways we still don't understand. Or it may not be fundamental at all, just a way we've evolved to make sense of changes in entropy, in information, in memory. In a universe where space and time can bend, stretch, and twist into singularities, or bubbles, or multidimensional fabrics, maybe we need to ask better questions. Not what was before, but what allows anything to happen at all. Not what came first, but why there is any order, any law, any framework within which moments can exist. The Big Bang may not have been a bang, and it may not have been the beginning. It may have been a ripple, a bounce, a transformation from something else to something we can barely glimpse, and can't yet explain. It may have marked the birth of time, or the latest act in an eternal play, or maybe it was the start of a story that doesn't have a first page. What do you see when you close your eyes and imagine nothing? Most people picture blackness, a blank canvas, a dark void, silent and still. But even that is something. Darkness is not the absence of existence, it's the absence of light. And the moment we imagine a void, we've already created a stage, a backdrop, a somewhere. Nothing is harder to grasp than we think. Not because it's complicated, but because it's too pure for our minds to hold. Our brains evolved in a world of things, rocks, rivers, stars. A world where everything has texture, weight, shape. So when we try to picture nothing, we inevitably sneak something into the picture. A space, a sense of time, a perspective, a boundary. But what if there never was nothing in the way we imagine? In physics, the vacuum of space might seem like nothingness, but it's not. Even in the darkest regions between galaxies, places billions of light years from any star, space hums with activity. Tiny quantum fluctuations constantly flicker in and out of existence. Particles and antiparticles appear and vanish in pairs, borrowing energy from the uncertainty of the universe and giving it right back, like sparks in a storm we can't see. This is the quantum vacuum. And it's not empty. It's a restless sea of potential, always on the edge of becoming. It turns out, nothing in physics is just a lower energy state. A vacuum is simply the minimum possible energy configuration of a field. But even at this minimum, it's never truly zero. There's always a jitter, a tremble, a dance of possibilities under the surface. If that's what nothing is at the quantum level, then we've never truly known emptiness. Because even when we remove all particles, all heat, all radiation, even when we strip space down to its rawest form, it still contains structure. Laws still govern it, fields still define it, time still ticks, however gently, and space still stretches, ever so slightly. This has led some physicists to a radical idea, that nothing doesn't exist, not in the way we want it to, that the absence of everything is not only unreachable but perhaps meaningless, that in the language of the universe, nothing is not a valid word. Even the idea of creating something from nothing, like the birth of the universe, may not require an absolute void. If space can fluctuate, if laws of physics can operate, if time can unfold, then that nothing already contains a lot. Some theories of cosmology describe how our universe could emerge from a quantum vacuum, from an eternal sea of fluctuations. A single, rare event could spark a self-sustaining bubble, a universe with its own space, time, and energy. In that sense, the Big Bang might be more like a phase transition than a divine spark. A shift in the vacuum state, like water freezing into ice, only on a cosmic scale. But again, the vacuum isn't nothing. It's governed by equations. It operates under rules. It allows things to happen. So we're left wondering, has there ever been true nothingness? A state with no laws, no space, no time, no structure, no potential. Can such a state even be imagined? Some philosophers argue that the very concept of nothing is incoherent, that it's a product of language, not reality, that by saying the word nothing, we imply a category, a placeholder, an idea, but ideas are not nothing. Try for a moment to think of a state where there is no space, not even a vacuum, no time, not even the silence between two events, no laws, not even the possibility of one thing becoming another, no observer, no canvas, no story, even the effort to imagine this causes our minds to reach for something, because consciousness itself needs a stage, and if that stage vanishes, so do we. Perhaps that's the root of the illusion. We ask, why is there something rather than nothing? Not because the question has a clear answer, but because we're shaped to ask it. Our biology, our culture, our syntax, it all orients us toward cause and effect, toward before and after, toward something coming from something else. But what if something is the only option that ever existed? Even when we speak of a void, we picture a volume. Even when we talk about silence, we imagine it contrasted against sound. We don't truly know how to think about absence without also invoking presence. It's as if our thoughts are wrapped in the very fabric of existence we're trying to escape. Some theoretical models try to tackle this head-on. They describe a timeless quantum state from which space-time itself could emerge, a realm beyond causality, beyond measurement. But again, these models are not describing nothing, they're describing a different kind of something. One with unfamiliar rules, but rules nonetheless. Others have suggested that perhaps nothing is unstable, that existence is inevitable, that the zero state is not a resting point, but a spring-loaded trap, that as soon as nothing exists, if that even makes sense, it instantly flips into something. But why? That's the part we still don't understand. Because even if we say the universe came from a quantum fluctuation, or a vacuum decay, or a higher dimensional brain collision, we're still assuming that the ingredients for that fluctuation, decay, or collision already existed. We're explaining something using other somethings, and if we try to dig deeper to ask where those ingredients came from, or where the laws that govern them came from, we eventually hit a wall, a silence, a place where questions echo but answers do not return. Some thinkers suggest that perhaps nothing is not the opposite of existence, but a different expression of it, that nothing and something are two sides of the same coin, that the universe arises not from the absence of everything, but from a tension between presence and potential, that what we call nothing is simply a state we do not yet understand, a dimension folded so tightly it appears empty to us, but hums with power just beyond our reach. Others suggest that reality is fundamentally mathematical, that numbers, relationships, and symmetries exist independently of space or time, that the universe exists because mathematics does, and mathematics can never be nothing. In that view, nothing is not the absence of matter, but the absence of structure, and structure is eternal. But then again, even eternity is a kind of something. It's no wonder, then, that the idea of nothingness has captivated and frustrated thinkers for centuries. From ancient metaphysics to modern cosmology, the question remains open, not because we haven't found the answer, but because the question itself may be flawed. The universe, it seems, doesn't operate on the same categories we do. It doesn't owe us a beginning wrapped in pure emptiness. It doesn't conform to the human longing for origin stories. We may never find a version of nothing that satisfies our desire for an ultimate starting point, because every time we reach for it, we find that it slips through our fingers, not because it's elusive, but because it was never there in the way we thought. Imagine we're standing on the edge of existence itself. Nothing behind us, nothing ahead, no space, no time, no consciousness, not even blackness, no distance, no silence, no waiting, not even the concept of waiting, just nothing. But the moment we try to imagine this, we fail, not because we're not creative enough, but because absolute nothingness may not be logically or physically possible. The mind demands a stage to think on, even when that stage is empty, and in doing so, we violate the very premise of nothingness. We project something, always. The idea that nothing could be impossible seems, at first, to contradict our intuition. Shouldn't the absence of all things be the simplest of all realities? No laws, no rules, no matter, no energy, no space, no logic, no order. But perhaps simplicity doesn't mean possibility. Maybe the nothing we speak of, a true, total, absolute nothing, isn't just uninhabited, it's unthinkable. Philosophers have wrestled with this for centuries. In ancient Greece, Parmenides argued that nothingness cannot exist, that to speak of it is to make it something, that what is not can never be. In his view, reality is full because it must be. Being is, and non-being isn't. Fast forward to modern times, and we find the same thought echoing in the corridors of physics. If there was ever a state of total nothingness, by what mechanism could it become something? If nothing contains no laws, no potentials, no properties, then what could ever cause it to change? This question hides a trap, because even asking what caused the change assumes time exists, assumes cause and effect, assumes possibility. But in true nothingness, all those things vanish. Time doesn't tick. There is no before or after. So the very notion that nothing could evolve into something becomes incoherent. And this is where the paradox sharpens. If nothingness cannot become something, and yet we exist, then perhaps the reason is simple: it was never truly nothing to begin with. Some theorists suggest that nothingness is inherently unstable, that it cannot persist, that the absence of everything is not a stable vacuum, but a kind of false floor, always ready to collapse into being. But that implies that even nothing has properties, that it can decay, that it is subject to laws, and laws are not nothing. Even if a quantum vacuum gave birth to the universe through a fluctuation, then that vacuum existed. Even if time itself emerged from timelessness, the possibility for that emergence existed. We end up circling the same idea again and again. Something always seems to be hiding behind the nothing we try to define. The deeper we go, the more we discover that nothing is never truly empty, that it carries the fingerprints of existence, faint but persistent, that the universe, in all its vastness, complexity, and beauty, may have never come from true void, but from a realm where void and presence are illusions we apply to something deeper. Modern cosmology doesn't shy away from these questions. Some models, like the Hartle-Hawking no-boundary proposal, suggest that the universe didn't come from nothing, but from a state where classical notions of time and space don't apply. A kind of rounded, finite structure with no edge, no beginning. In this view, the universe is not born, it just is. And again, that's not nothing. String theory adds even more layers. It suggests that what we perceive as particles are vibrations of tiny strings existing in higher dimensional space. That space itself is woven from these vibrations. That our universe could be one membrane floating in a higher dimensional bulk. That collisions between these membranes may create new universes. If so, then our Big Bang wasn't the beginning of everything, just the start of our local pocket of something. And that pocket might be surrounded by more something. Always more. So, where's the nothing? If every theory requires structure, fields, strings, dimensions, potentials, laws, then perhaps nothing is not part of physics. Perhaps it never was. Perhaps it's just a word, a placeholder, a ghost idea left over from the limitations of language. But the mystery remains. Why is there something rather than nothing? Some philosophers turn the question around. Maybe it's the wrong question. Maybe it's like asking why blue isn't square. Maybe nothing was never a valid alternative to begin with. Maybe being doesn't need a cause. Maybe existence is fundamental, eternal, irreducible. This would mean that the very concept of nothing is a mental abstraction, not a metaphysical reality. We can say the word, we can imagine the shadows of its meaning, but we can't reach it. It's like chasing the edge of a shadow, it disappears the closer you get. Even mathematically, defining nothing proves elusive. In set theory, the empty set is a collection with no elements, but it's still a set. In logic, the null value means undefined, but it still plays by the rules. In topology, an empty space still has properties, still has dimensions, still fits inside a larger structure. And so the more we search, the more we realize every attempt to define or imagine nothing drags something along with it. A container, a context, a framework, a mind. In that sense, the impossibility of nothingness might be less of a scientific conclusion and more of a philosophical awakening, a realization that we are embedded in a reality where absence is not the default, where presence is not an accident, where being might be the ground state, not a temporary deviation, but the only state that ever was. If true, this shifts everything. We often imagine the universe as emerging from nothing, as a blip in the void, as an improbable miracle. But if nothing is not possible, then being is not a miracle. It's the norm, it's the fabric, the ocean in which all things float. And yet, we still long for the nothing. We still ask the question, because behind the science, behind the philosophy, there is a deeper emotion, a sense of awe, and perhaps confusion, that anything exists at all, that we can think, observe, reflect, wonder. We are the universe becoming aware of itself. And in doing so, we can't help but ask, what was there before? But maybe the question isn't, what came before existence? Maybe the real mystery is, why did we ever think there could be something else? Because perhaps the impossibility of nothing is not a limitation, perhaps it's the greatest truth. We've never fully understood. Close your eyes. Strip away the stars, the planets, the galaxies. Remove time. Collapse every dimension. Imagine an expanse so empty that not even blackness exists, because blackness itself is a color, and that, too, must vanish. What you're left with, or think you're left with, is nothing. But you'd be wrong. Even here, in the deepest reaches of conceptual absence, something stirs. That something is the quantum field. In modern physics, the idea of nothing has quietly dissolved under the lens of quantum theory. What was once thought of as empty space is now understood as a boiling, restless arena of fluctuating energy. Quantum fields stretch across the entirety of the universe, not as particles or matter, but as fundamental fabrics from which all things arise. They are not made of something. They are the something, and they never rest. Even in what we call vacuum, a space from which every particle has been removed, quantum fields still exist. They cannot be extracted, switched off, or erased. They are always present, always active, always vibrating at the smallest scales. These fluctuations, known as quantum vacuum fluctuations, are the reason why nothing is never truly nothing. This isn't metaphor or speculation, it's measurable. In fact, the very presence of these fluctuations is responsible for real, observable phenomena. One of the most famous is the Casimir effect, where two uncharged metal plates placed close together in a vacuum will experience an attractive force, not because of gravity or any classical interaction, but because the quantum fields between them behave differently than those outside them. The vacuum is doing something, and yet, we still call it nothing. In quantum field theory, every type of particle, electrons, quarks, photons, is an excitation of its respective field. When you observe a particle, you're not seeing a speck of matter floating in space. You're seeing a ripple, a localized wave, a disturbance in a fundamental field. The particle is not separate from the vacuum. It is an expression of it, which means the vacuum holds within it the potential for everything. It is not emptiness, it is potentiality, a hidden code humming beneath existence, even when all observable objects are gone. In this sense, what we casually refer to as nothing is actually a deeply energetic, profoundly structured system. This redefinition of nothing has enormous consequences. It reshapes the way we think about the birth of the universe. In the classical view, the universe began with a bang, a sudden explosion of something from nothing. But quantum theory complicates this. If vacuum is already teeming with energy, if fields are always present, then perhaps the universe didn't emerge from a true void, but from a quantum vacuum in a high energy state, primed for transition. Inflationary cosmology takes this idea and expands it. It proposes that, in the earliest moments of existence, a field known as the inflaton filled space with a uniform energy. This energy caused the universe to expand exponentially fast in a fraction of a second, flattening and smoothing it out. Then, as the field decayed, its energy converted into particles, light, and matter. The universe as we know it, every star, every atom emerged from that transformation. But where did the field come from? Again, we reach the limits of language. If the field existed, then we were never dealing with nothing to begin with. If the field can appear spontaneously, then it did so within a context, a framework where quantum mechanics applies, where transitions are allowed, where fluctuation is real. And so, the illusion of nothingness deepens. The Heisenberg uncertainty principle teaches us that energy and time are inextricably linked, that over very short durations, energy can spontaneously appear and disappear, as long as the total balance is maintained. These tiny bursts of virtual particles bubble into and out of the vacuum constantly. They don't violate conservation laws, because they exist on a borrowed timeline, but their effects are real. They influence particle behavior, shift energy levels, and even alter the trajectories of particles. Again, the vacuum does something. In fact, some scientists believe these fluctuations might be the seeds of the universe itself. In a state of perfect symmetry, quantum fields might balance so precisely that the net energy of the universe is zero, positive energy in the form of matter balanced by negative energy in the form of gravity. In such a scenario, it becomes theoretically possible for a universe to emerge from nothing without violating any conservation laws. But here, nothing is already a something, a stage with rules, properties, and potential, which leaves us with a haunting realization. The nothing we long to define, the true, complete, unstructured void, has never been observed, never been measured, and may not even be logically coherent. Instead, every step we take toward emptiness only reveals deeper structure, a richer field, a subtler hum. At the Planck scale, where quantum mechanics and gravity meet, space and time themselves may dissolve into foamy uncertainties, a blurred dance of probabilities where the classical idea of nothing is just another illusion cast by the limits of human understanding. And yet, this illusion persists because it feels so intuitively real. We see an empty room and call it nothing. We stare into space and call it void. We dream of a state before the universe, a blank slate waiting to be written upon. But at every scale, At every level of analysis, we find something hiding there. A field, a fluctuation, a chance, even in the coldest possible vacuum, cooled to near absolute zero, where no particles move, no photons shimmer, and no sound can exist, quantum fields remain. They ripple gently, secretly, perpetually. They are the music of the universe, even when there is no audience. They are the painter and the canvas, waiting to erupt into form. And so we return to the question we cannot escape. Was there ever truly nothing? In the quantum world, the answer seems to be no, because science forbids it, but because nature doesn't require it. The universe is not built from nothing. It is built from fields, potentials, and the rules that allow them to awaken. And those rules are not imposed from the outside, they are intrinsic, inescapable, eternal. The idea of nothingness is like a shadow we chase across the floor of reality, always ahead of us, always fading as we approach. Because wherever we look, however deep we go, the universe whispers not emptiness, but presence, not absence, but emergence, not silence, but the echo of a field vibrating through the void. If there was never truly nothing, then what does that say about our deepest assumptions about existence, origins, and meaning? Philosophers, long before the birth of particle physics, or quantum fields, wrestled with the simple question, why is there something rather than nothing? It's a question that isn't just scientific or religious, it's existential. It reaches into the corners of our identity, our beliefs, and our very notion of what it means to be. We tend to think of nothing as the default state, the canvas before the brush, the silence before the song. In our human storytelling, something comes after nothing. The universe is born out of a void. Consciousness arises from the absence of thought. Creation begins when there is first emptiness. But what if this entire frame is backward? What if nothingness never was not, because we can't get there physically, but because it doesn't, and perhaps never did, actually exist? From the philosophical angle, the impossibility of nothingness becomes less of a scientific oddity, and more of a metaphysical revolution. If something has always existed, whether in the form of quantum fields, potential laws of nature, or even pure information, then existence itself is not contingent on a beginning. It just is. And in that realization, we face the collapse of a comforting story we've told ourselves for millennia, that there was once a clean, absolute beginning, a single moment of becoming. If there was never nothing, then we're not just the children of a cosmic explosion or an act of divine will. We are the inevitable unfolding of an eternal structure, an infinite recursion of existence recombining and reshaping itself across unknown scales of time and space. The difference might sound subtle, but it's profound. One perspective sees the universe as a product of creation, the other sees it as an unbroken expression of being. Consider what it means to live in a cosmos where nothingness is impossible. In such a framework, there can be no ultimate erasure, no absolute end. Energy is conserved. Information is never lost. Even in death, even in destruction, something remains. Entropy may disperse the order of systems, but the constituents persist. Memory fades, but the atoms continue, recycled endlessly into the next formation. That means meaning itself is not a transient flicker in the darkness, it is embedded in the continuity of being. It is always present, simply shifting forms. We are, then, not anomalies in an empty void. We are expressions of a system that does not know emptiness. We emerge from a universe that doesn't flicker into existence from nothing, but rolls forward from its own prior state, which may itself be infinite, eternal, or dimensionally beyond comprehension. The idea that nothing is the opposite of something becomes fragile. Perhaps they are not true opposites at all. Perhaps nothing was just our primitive attempt to imagine the absence of what we see, feel, and know, a placeholder word for a state we can never actually prove. This philosophical reframing also shifts how we interpret our search for meaning. Many thinkers have anchored morality, purpose, and identity in the contrast between being and nothingness. Martin Heidegger wrote of being toward death, the idea that human existence is defined by our awareness of its end. Jean-Paul Sartre explored How the void in our consciousness grants us freedom and dread. But if metaphysical nothingness does not exist, if it's an illusion born of limited perspective, then we must reimagine these foundations. We are not defined by our proximity to non-being, but by our participation in continuous being. We are not creatures perched at the edge of a void, but waves rising on an ocean that has no shore. This also leads to an unsettling realization. If something is the default state, if being is foundational, then the real philosophical mystery isn't why there is something rather than nothing, but why we ever believed in nothing at all. Where did that idea come from? Why does our mind crave the notion of absence, void, and total erasure? Is it rooted in our fear of death, our experience of loss, our inability to see beyond our limited dimensions? Perhaps the concept of nothing is not an insight about the universe, but a projection of human limitation, a product of our finite perception. The human brain is a master of contrast. We know light because we've known darkness. We recognize silence only after noise. So perhaps we imagine nothing to make sense of the something that overwhelms us. But just as darkness is not a thing in itself, it is simply the absence of photons. Maybe nothing is not a real thing, but merely the absence of phenomena we expect to find. When stripped away, it reveals not a void, but something else entirely, a different kind of being, one we may never fully understand. This changes the way we think about cosmology and even theology. Religions have long posited creation from nothing as a mark of divine power. The phrase creatio ex nihilo, creation out of nothing, stands at the heart of many theological doctrines. But if science now tells us that nothing is physically incoherent, that fields and laws are always present, then creation itself may need a new definition. Not an act imposed on a blank slate, but an emergent phenomenon unfolding from the properties of a pre-existing system. A process rather than an event, a flow rather than a spark. This also brings into question the human craving for beginnings. We want origin stories. We want to know what started it all, who started it all, and why. But what if that need is a relic of our storytelling brain, not a feature of the universe? What if the cosmos has no beginning, only transitions, no point of origin, only states shifting endlessly forward and back? That would mean that every first cause we imagine is just a step on a ladder without a bottom rung. The absence of nothing also reshapes how we experience time. If the vacuum is not empty, if fields continue even when all motion stops, then time too may be something more fundamental than we think. Perhaps time does not pass over a backdrop of nothingness, but is woven into the field dynamics themselves. In other words, time is not a river through emptiness, it is the changing vibration of being. And if the universe was never at rest, then time has always been flowing. From the ancient voids of mythology to the silent vacuums of Newtonian space, humanity has always imagined a place where nothing exists. But what we now understand is this: even in the farthest reaches of intergalactic space, even in the coldest, loneliest corners of the cosmos, there is activity, there is structure, there is something. The canvas we thought was blank is alive with invisible brushstrokes. In this way, the philosophical implications of never having nothing are not just abstract, they are intimate. They touch how we see death, how we define birth, how we understand continuity, permanence, and even hope. A universe without nothingness is a universe where change is constant, but loss is never total, where the disappearance of one form always gives way to the emergence of another, where the story never stops, only shifts. What if our entire understanding of reality has been shaped by a false premise that at some point, nothing existed, that there was once a blank page upon which the story of everything was written? But if that page never existed, if there was never truly a nothing, then the story didn't begin, it simply always was. And if that's true, then reality is not a book with a first page, but a loop, a pulse, a song without a composer that has been playing forever. To rethink reality through the lens of never nothing is to challenge the most intuitive beliefs we hold about causality, identity, and even existence itself. Because baked into our understanding of the world is a subtle assumption that things come from somewhere, that something is born from nothing. But if nothing is not real, then things don't emerge, they continue. And that one shift collapses centuries of metaphysics, and it opens up an entirely new frame for everything we know. We live in a reality that seems filled with opposites. Light and darkness, being and non-being, life and death. But the concept of never nothing softens these contrasts. It tells us that opposites may not truly be opposites, they're transitions, thresholds, illusions formed at the boundary of understanding. There may not be a sharp line between something and nothing, because nothing may never have existed to begin with. The duality breaks down, and in its place is a strange continuity. In such a reality, death is not a return to nothingness. It is a transformation into something else, perhaps something unimaginable. Just as a star collapsing becomes a black hole, or a thought becomes a memory, so too does every form pass into another. There is no erasure, only rearrangement. Every breath you take is made of atoms that once swirled in ancient stars. Every molecule in your body has existed for billions of years, recombining endlessly, never ceasing to be. And this doesn't just speak to the poetry of science, it speaks to the foundation of reality itself. The idea that there was never nothing means the universe never started from scratch. It was never empty, never quiet, never neutral. The fields that sustain particles were always there. The laws that dictate their behavior were never turned off. And so, anything we know, light, matter, time, may not be the product of a beginning, but the result of an eternal process unfolding from one configuration to another. That's not a big bang born from a void. It's a transformation from one state of being to another. In that light, reality begins to look less like a construction and more like an evolution, less like a sudden spark and more like a gradual unfolding of potential. We stop thinking of existence as something that started and more like something that simply always was, and that changes how we place ourselves within it. We're not newcomers to a freshly built universe. We are participators in a timeless system that's been flowing long before we had words to describe it. This shift also reframes how we understand consciousness. If reality never came from nothing, then neither did awareness. Perhaps the ingredients for consciousness have always been embedded in the universe, waiting for the right conditions to emerge. Perhaps our minds are not isolated phenomena, but brief flickers of an eternal field of information, like waves rising on a quantum sea. The ancient Vedic texts whispered of something similar, that consciousness is not created, but revealed. Not sparked into being, but uncovered. And science, slowly, is catching up to that poetic intuition. Quantum physics has blurred the line between observer and observed. Information, some say, may be more fundamental than particles themselves. Fields, not points, are what give reality its substance. And in this strange framework, the concept of nothing becomes not just outdated, it becomes meaningless. Reality is not a thing sitting in a vacuum. Reality is the vacuum itself, or more accurately, the vacuum that isn't empty, a field that isn't still, a silence that hums with potential. When we remove nothing from our model of existence, we also change our relationship to time. We stop asking, when did it all begin? And start asking, what came before what we call the beginning? And then, what came before that? And the further we go, the more we realize that we are chasing a horizon that never arrives. Because if there was never nothing, then there was never a clean start. Only a shifting of state, like a fire that changes color, but never goes out, or a river that turns, but never dries. This has radical implications for our understanding of the self. We often define ourselves through contrast. I was born at this point, and I will die at that one. But if the fabric of reality never stops being, then we are not defined by our beginning or end. We are defined by our participation in the flow. You are not a fixed point, but a wave. You are not a thing that appeared, you are a process in motion. And that process does not begin or end with your heartbeat. It stretches backward into stardust, and forward into whatever shape you next become. This also changes how we understand hope, purpose, and meaning. In a reality that rose from nothing, Life can feel like an accident, random particles briefly aligning before vanishing back into the void. But in a reality that never had nothing, existence is not a temporary glitch, it is a permanent condition. The specific shapes may change, but the song continues. Meaning is not imposed from outside, it is part of the structure itself. To exist is to be part of that ongoing melody, and when you truly let that idea settle into your bones, it softens the fear that often hides beneath our questions about existence. We are not dangling above an abyss. We are not standing on the edge of a precipice. We are floating in a sea that has no bottom and no shore. A sea that never began and will never end. A sea where every ripple, no matter how small, continues to move the whole. It's tempting to see this as mystical, to frame it in spiritual language. But it's not necessarily about belief, it's about reframing our assumptions. It's about questioning the stories we've inherited. It's about letting go of the idea that things only have value because they're rare or temporary or born from voids. Maybe their value is precisely in their continuity, in their inevitability, in their presence. So, what is reality if not a battle between being and nothing? Maybe it's simply being, full stop. Maybe it's always been. Maybe everything we've ever known, loved, touched, or dreamed is not a flicker in the dark, but a strand in an unbreakable tapestry. Maybe you are not an exception to the universe, you are its echo. And so, the idea of never nothing is more than just a scientific proposal or a philosophical position. It is a lens, a way of seeing, a method for peeling back the assumptions and reimagining the foundations. Because when you stop believing in nothing, you stop fearing loss, you stop seeking a beginning, and you start listening for the patterns, the rhythms, the truths that were always there, hidden not behind silence, but within it. So here, we are, after wandering through fields of ancient philosophy, diving into the paradoxes of quantum physics, brushing against the edge of time, and dismantling the very idea of nothing. And what have we found? Not answers, perhaps, but a quieter mind, a slower heartbeat, a strange and beautiful awareness that everything, every grain of sand, every breath, every flicker of thought belongs to a continuum that never broke, that never paused, that never had to begin because it was already flowing. Always. What we thought of as nothing turns out to be a shadow cast by our own limitations, a placeholder we invented to explain what we couldn't yet perceive. But the universe, in its quiet indifference, does not traffic in emptiness. It dances in continuity, in symmetry, in becoming. Maybe that's all we are, becomings. Ripples of a reality that never needed to start, because it never needed to stop. We tried to ask, did nothing ever exist? But maybe the better question is, why did we ever believe it could? And in that question, whispered not for answers, but for stillness, we find something more precious than explanation. We find wonder, and maybe, just maybe, that's the point.